So if you're watching this, obviously I'm still in quarantine. Maybe I'll be back tomorrow. I'm actually recording this on Monday because it takes a long time to convert these things into things that YouTube will accept. And with the internet I have out here, it takes a while to get it onto YouTube. So I'm working a day ahead. Uh, anyways, last night you went home, you memorized unit circle, and I had mentioned that today I would try to show you how to use it. So that's kind of the goal of today. Shouldn't be too hard. Let me get my ImageMate software up here. Forgive me. We're having a technical delay here. There we go. Now I can write. So I'm just going to kind of make some stuff up. That's really all I'm going to do. I know full well you could use a calculator or whatever. The unit circle is one of the real points of memorizing it is things like this, because in calculus you're going to see stuff like this, and you're not supposed to go rely on technology and get distracted from the problem. You're supposed to know. If somebody asked you what the cosine of pi over 3 is, yeah, you could put your TI-84 in radian mode, and you could figure it out pretty simple. Well, what most kids do is they say, okay, that's really the cosine of 60 degrees. Now, I'm not going to redraw the unit circle here. I already know what the answer is. But when I was younger, what I used to do was I would think about where that point was on the unit circle. Just having that drawn out made it quicker for me. So, 60 degrees here, I kind of label it a little bit. And I just kind of think about how it went, what it took to get to that circle or that point. I ran to the right more than half a unit, so it must have been root of 3 over 2. And mine's not placed entirely, but what is? I did that wrong, didn't I? That's because I made it too complex for myself anymore. I ran to the right about half a circle, or half the radius, and I ran up root of 3 over 2. You memorized some stuff yesterday. You know full well that cosine is the x value. So the cosine of pi over 3 is just a half. And you can check that on your TI-84 if you want, but it does pay to have this stuff in memory. Sometimes people will ask you weirder things like, I don't know, cosine of 21 pi over 3. When we teach this in pre-calc, sorry, Mason is whining. I have traditionally taught kids to just convert this to a degree. First off, let's change this problem because I don't like it. Let's make that a 4. So 21 pi over 4. You can reduce this down a little bit, or you can just do the radian formula if you want. But you might think of it as 21 pi's over 4. And if you'll remember, pi over 4 is worth what, 45 degrees? So what's 21 45s? I'm going to go with 945. That seems right. 945 degrees is not an angle that lies on the unit circle. Well, the nice thing about the unit circle is if you travel 360 degrees, you get right back to where you start. So what we do is we take away 360 as many times as we can, okay? So if I take away 360 twice, I took away 720. 945 minus 720 should be 225 degrees. And if you memorize your unit circle, you know that's on there. Pretty sure it is anyways. 225 is about right here on the unit circle. And just having that up in front of you, I think, helps. But anyways, to get to that point, we went back a root of 2 over 2, and we went down a root of 2 over 2. And again, for some reason, I was asking about cosine here. So that's using the unit circle. So I'll make up another one here. I'll do something with tangent. And, well, let's make up a number here. something that doesn't work out too pretty. Can't make anything too pretty. Let's do negative. Negative 22 pi over 3. It is a negative angle. Uh, by the way, I'm teaching as though you know what pi over 3 is worth, which you should. But if you don't, you have to go to the old how to convert to a radian form or degree formula. You multiply by 180 over pi. Pi's cancel. 180 over 3 turns out as 60. You know, it's extra work. So I just jumped to here. But anyways, 2 times 6 is 12. So I've got 20 times 60. That's 1200. And another 120. I'm coming up with negative 1320 degrees, just off the top of my head. You are not happy, are you? You are not happy, are you? I'm going to pick him up real quick. I don't know how much of you can see, but this is my newest. This is Mason Lee Milbrath. His brother, believe it or not, is 2.5, and he can almost sing the quadratic formula. We've been working on that for a while. Mason, he doesn't do much. He just sit there with little face with no reaction. But he's only 2 months old. Oh, and he wanted to be held. All right, so where was I? Negative 1320. Now, I know Algebra 2 has been a while, but a negative angle rotates like a clock. You know, in the positive angle up above, I took away 360. When I deal with negative angles, what I do is I actually add 360. And you can add 360 several times, actually. 3/360s is 1,080. And if I add another 360, I'm actually adding a positive number. So I'm going to add 4 360s, which is, what is it, Mason? I'm actually adding 1,440 degrees. So I'm taking a negative angle and I'm thinking about it in a positive manner because it's going to be easier to work with. And that's a 120 degree angle. So through a little manipulation, we rewrote this ugly looking thing and we said it is equivalent to the tangent of 120. Oh, he's happy. He must like this lesson. It's equivalent to the tangent of 120 degrees. And then you can think about your unit circle. You can think about it in your head if you want. But 120 is about right here. And to get to that point, you went to the left a half a unit, and you went up a root of 3 over 2. Now, this is the tangent ratio. All right, tangent is to find the tangent of some angle, any angle on the unit circle, and any angle in general, is the sine of that angle over the cosine of that angle. So we're going to take the y value, root of 3 over 2, and we're going to divide it by this negative 1/2. We're going to do math without a calculator. 2's cancel. Positive over negative is negative. And there's your answer, negative root of 3. The only other thing I'm going to talk about with the unit circle is things that you're given and told they're on the unit circle. And I'm not going to sit here and create a problem that's actually correct at all. It's dead wrong, but the procedure is correct. So let's say you are told the point, I don't know, negative 11 33rds, and I'm not going to sit here and do Pythagorean theorem. 25 33rds lies on the unit circle. Okay? And we're going to expand this. What are the 6 trig ratios? So there's some stuff I haven't talked about here that you haven't seen in a while. It's okay. You'll remember it. Well, sine is easy. It's 25 33rds. Cosine is easy. It's negative 11 33rds. Tangent is easy. You know, we just take y and we divide it by x. So that's not too hard. 25 33rds divided by negative 11 33rds. 33's cancel, and we end up with a negative 25/11. So there's 3, but I mentioned 6. So I'm talking about the reciprocals. I always had a hard time memorizing if it was PRO or PRI. Reciprocals are pros, they're not pricks. Do you remember what the reciprocal of sine is called? Mason, do you know? Does Mason know? He's as clueless as y'all. Nothing going on up there. The reciprocal of sine is called cosecant. And we just abbreviate that CSC. And it is literally the reciprocal. So the reciprocal of 25/33 is 33/25. The reciprocal of cosine, that's usually an easy one for somebody in the South to memorize. SEC is called secant. And we just flip over here, negative 33/11. The reciprocal of tangent being called cotangent, abbreviated COT. And don't be that dumb kid who pronounces it cot. God. Whatever. Cotangent, kids. And reciprocate that. So 11/25. Don't forget about the negative. That's pretty much all we're going to do with instruction today. That shouldn't have taken you too long to see. So here's what I want you to do. I don't want a copy of your notes today. I want you to go to calculus. So log into IXL, go to calculus, and I'm actually going to assign it right now. And it's under C5. Do C5, okay? I'm going to assign it. Anyways, y'all have a good day.